Now, welcome everybody. It's Bruce here, and today I'll be covering the cnWave 60 gigahertz product, which is relatively new product for us, and very exciting times for this product as it's a lot of interest around the world, and also, specifically here in the U.S. So I'll be covering a number of topics. I'll start and cover a little bit of the technology, the background on Terragraph, and the technology that's underlying cnWave. I'm going to focus a fair amount of time on applications and use cases because that's really where I see this is quite a bit different if you're coming from the fixed wireless broadband point to multi-point, point-to-point solutions in the sub 6 gigahertz. The way this is deployed, the way this is used is quite different. So for those of you that are new to 60 gigahertz, hopefully that will give you some ideas on how it might be deployed. Then I'll cover the product components themselves, and we'll certainly have plenty of time at the end for questions, so Q&A at the end. And so I would think the presentation will be about 35, 40 minutes, and then we'll jump into some Q&A. Please go ahead and put those questions into the chat box as soon as as they come to mind, and we'll get after those as the presentation wraps up. So with that, I will get started. Just a real quick or brief intro. cnWave is our 60 gigahertz solution. You'll see, and I'll go into these in much more detail, but it's really composed of a couple different devices. We have our distribution node, which is the V5000, that can serve as kind of the traditional hub in a hub and spoke, or as a point-to-point, or as a sort of a entry point for a mesh environment. We'll talk about that in quite a bit more detail. Then we have a couple of different client nodes, V3000 for longer range, and the V1000 for lower cost, or putting at, say, a residence or a business at the sort of end of the network. You'll see a couple of logos up here. Terragraph certified. Terragraph is a technology developed and put forward and progressed by the Facebook connectivity group. That is the technology that underlies and takes the 802.11ay standard and starts to put some product requirements and solution requirements around that to build sort of an ecosystem of Terragraph certified devices, and Cambium is leading the way in this with the Terragraph certified cnWave. You'll also see cnMaestro up in the upper left. As with almost all of our products now, you can manage this, and really works best if you manage it with cnMaestro. So I'll cover that as well. cnMaestro is the network management system supporting, like I said, cnWave, but also the sub 6 products and our Wi-Fi products, and pretty much all down the line. So a couple things that are interesting to keep in mind about cnWave. It is giving multiple gigabits per second, and we'll talk about what that means with dual sectors and channel bonding. And but suffice it to say, this is a very high capacity network delivering gigabits per second, and certainly lots of capacity for different applications. What makes it particularly easy to install for both the distribution node and the clients is that this uses bidirectional auto beamforming. So the beam forms both from the distribution node as well as the client node, so that you can really simplify the installation process for this, and we'll get into some of that as more detail as well. When you deploy this as a mesh topology, you can get a lot of healing, resilience, ability to reach areas that are not line of sight. So you can get after some of those locations that are behind buildings by going around them with mesh, and then the ability to automatically expand or heal that network as the network environment changes. The topologies I mentioned, mesh, of course, is the big game changer here with the 802.11ay, but also we support the point-to-point and point-to-multipoint topologies. And I mentioned cnMaestro. A little bit about 60 gigahertz, the spectrum and the background. The spectrum's been in use for quite some time. I think there's networks going back 10, 12 years even. but those were based on either pre-802.11ad or the 802.11ad standard. And what's emerging now is the 802.11ay standard. And I'll just highlight a couple of the differences. So if you have been using 60 gigahertz in the past, here's what you can expect as we go forward into the new era of 11ay. For one thing, the capacity is doubled, so the PHY throughput is up there over 9 gigabits per second. The channel width is similar channels, so the channel layout, there's, depending on where you are in the world, there's either 2, 4, or 6 channels available. The cnWave solution can use channels 1 through 4, and coming soon will be and when I say soon, I'm meaning sort of towards the end of this year, is channel bonding, which allows you to combine 2 channels. These are 2.16 gigahertz channels or 2160 megahertz channels, so very wide channels if you're thinking or coming from a background in the sub-6 environment. And channel bonding will allow you to put 2 channels together and in many cases double the capacity and increase the available capacity in the mesh or out to the end nodes. One of the key things that helps 11ay products or solutions scale up is that 11ay uses TDMA and TDD interfaces versus 11ad was using the CSMA carrier sense technique to gain access to the channel. So with the TDMA TDD circuit, you're able to see the interface is scheduled. Client nodes can request access and request bandwidth. So it's a much more controlled environment. And it also allows us to do things like, and in fact must do GPS synchronization so that you can synchronize all these nodes and reduce self-interference and reduce overall interference in the network. So network synchronization, another benefit there. Of course, mesh is the big driver for a lot of these solutions and applications, and the number of CPEs per sector increases up to 15. So some of those advantages I highlighted, but I'll just hit on them again right here real quick. TDMA, being able to have lots of devices in an area with minimal self-interference is important. This is kind of a hallmark of Cambium's fixed wireless solutions in point-to-multipoint environments. So using both synchronization and TDMA, TDD solutions is something that if you've been using our point-to-multipoint or ePMP products, you're quite familiar with. Channel bonding, so this is the ability to combine 2 channels and in most cases double the throughput. Mesh routing is the other piece that leverages some capabilities called OpenR and the ability to do find particular routes through the network and do automatic expansion and healing. And you'll see that if you get into the some of the configuration and setup of these products, you'll see how easy it is because everything is driven from the E2E controller that pushes the configuration and setup and healing and expansion of the network all from that and E2E controller, and really simplifies the maintenance of the network. So how is 60 gigahertz typically deployed? This is more of a theoretical slide, and then I'll jump into some specific examples. So the deployment architecture here, you can see the first one here is wireless to the home. So you can think of this as providing broadband access directly to a residence or small business, individual end user at that end node, at that endpoint. Wireless to the building. So this is, think of this as a office building, multi-dwelling unit. So an apartment building, think of it as hotels, businesses, where you bring in the broadband multi-gigabit per second capacity to the rooftop and then disperse it or distribute it through the network either via wire or Wi-Fi. Rooftop to rooftop, this is really another sort of topology for connecting campuses, connecting buildings that are down the street for enterprise access. And then again, that multi-dwelling distribution. So if you have a series, imagine an apartment complex or a condo development, or even a college campus, or building business community. Fiber extension. So one of the things that 60 gigahertz assists with, so it kind of competes with, but also complements, is fiber deployments. So if you have the traditional challenge with fiber is that it takes a long time and is expensive to deploy. So 60 gigahertz wireless is a great alternative to that, as you can bring customers online much more quickly. You can extend that fiber across major highways or down historical areas in that they don't allow you to trench or run aerial fiber. Gives you some options to extend and still provide fiber-like speeds, but in a wireless fashion that's quick to deploy. And then, of course, backhaul is another aspect, whether you're backhauling outdoor Wi-Fi access points, backhauling 5G small cells, or even doing video surveillance and CCTV applications with video cameras. So that's kind of a theoretical view of quite a few different topologies. In all cases, those can be deployed as either point-to-point links, point-to-multipoint links, or mesh. So think in terms of the same building blocks of cnWave can be deployed in all those different ways. And within that wireless fabric, when we talk about our cnWave multi-gigabit wireless fabric, that is complementary to our Wi-Fi access points. So we have, Cambium has a whole suite of indoor and outdoor Wi-Fi access points, as well as wireless aware switching, Ethernet switching with our CN Matrix product line, the CN Pilot product line for Wi-Fi. And of course, it can also complement our broadband sub-6 and licensed microwave solutions as well. And they all come together in that Cambium cloud management using CN Maestro. So let's look at some specific examples. I'll start with some service provider applications. So this is typically a 60 gigahertz deployment in a city center or large urban environment. And typically this includes the topologies we started out talking about, which is rooftop to rooftop, point to multipoint with mesh, and complementing that with Wi-Fi. So here's an example. This is a large carrier called YTL that is doing a cnWave deployment in this city area that you see here. This network is made up of multiple devices. The red dots there are the V3000 distribution nodes. The dark purple are where there's fiber access points or fiber entry points into the network. And then the light blue dots are the CNs or client nodes. And what they're using this for is both residential and business access, but also feeding a citywide Wi-Fi coverage solution. So this just gives you an idea of how these are laid out, and you can kind of see the density of the network. Each individual link is relatively short. Think in terms of 100 yards to 100 meters to maybe a kilometer at the most, and typically in a couple of hundred meters as a typical range for how these are deployed. And this is leveraging the mesh application. Similarly, here's another deployment with a smart city application. And this is really also providing outdoor Wi-Fi coverage for the citizens of the community, but also for some of the municipal workers and access to the city network through a combination of cnWave mesh network and Wi-Fi. As we start to move out of the city centers and you get into suburban deployments, and I'll mention also as we move closer to rural deployments, you'll start to see the links spread out a little bit and the density start to drop a little bit, but you still see that same view of distribution nodes forming a mesh. You can kind of see that blue outline of a ring, and then client nodes hanging off as spokes off of those distribution nodes. And then in some cases, Wi-Fi as you enter either the home or the smaller area. And similarly, if you're a service provider providing this as complementary to your 5G communications, very similar application. Now here's an example as we move further into the rural areas. Sometimes people say, oh, well, if this can only go a couple hundred meters, is it really a solution for the wireless ISP that is typically serving more of a rural environment? And as I move out from the suburban environments into rural, is there application? So this is kind of giving you an indication that even in the rural environment, we see lots of smaller either subdivisions or villages that can be addressed with 60 gigahertz cnWave. So here you can see this looks like a smaller farming community, and within that community, there can still be lots of applications to deliver, in this case, 100 megabits per second plus services, but as high as gigabit per second services to deploy cnWave broadband services to all of these individuals, citizens. So it can really complement the broadband connection that you might be feeding out into the further away from this village, but certainly you can see the build out within the community, covering lots of subscribers within that area. Also move into enterprise. With the enterprise, it's similar. You have rooftop to rooftop, but also multi-point and mesh. And a couple of examples here. This is a deployment in a campus environment where they've built a mesh around the core of the campus. You can see the red lines with our distribution nodes forming that internal mesh. And then hubs, those serving as the hub to the spokes going out to different client nodes. You can see an example there of crossing a highway where fiber would really be a non-starter there, and then also being able to extend to additional buildings around that campus area. So whether it's a management company that's providing broadband to their clients, or an actual standalone enterprise that's trying to provide connectivity from building to building, either overlaying an existing fiber network or augmenting it with a backup communications. This becomes a nice solution for enterprise. Another application, this is a chemical production facility. So it's for an industrial IoT application. And here you can see an interesting application where the design is a very dense deployment of distribution nodes in a very dense mesh. And what this customer is looking to do is provide lots of capacity, inject lots of capacity into the network on a nice grid pattern, and then be able to use that grid and mesh as a reliable video surveillance, security, as well as process control and automation backhaul for their industrial IoT solutions. Another application, and I know I'm hitting you with lots of these, but we have literally, I think we're growing every day as far as the number of deployments, but I think we're up beyond, we originally did this with around 40 or so proof of concept trials, but now we're adding new networks almost on a daily basis. So the number of examples just continues to grow. Here's one in a rail yard application. And here you can see down the length of the rail yard, distribution nodes at both sides, and then a couple of cross points to provide that mesh or resiliency. And this is really to provide both video surveillance for security applications and process monitoring, as well as Wi-Fi for the employees and fieldcraft workers in the field to be able to access the corporate network, and also provide some process automation in trackside communications. And last but not least, we'll talk about 5G small cell backhaul. So again, this would be for service providers looking to do backhaul to small cells that they might not be able to get fiber directly to, and that could either be because they don't have the time or ability to trench fiber to those locations, but they still want to provide that capacity or coverage with their small cell. So typically with a small cell, you're either looking to extend your coverage into areas that you couldn't quite reach with the macro cell, or you're trying to put additional capacity into areas where you have lots of people congregating and getting access to the network. So typical small cell backhaul deployment. Here's an example of a street where they're using a relay node. You can see here from point A to point C, it's still only, if I look up on the map there, it's it's not very, it's only maybe 100, less than 100 meters or so from point A to point C, but you don't have line of sight. So using cnWave and the ability to do relays with our V5000, you can make a connectivity from, or a connection from point A to point C through that relay node point B. And if you look down in the lower left, the images, again, difficult to string fiber or trench fiber in this kind of environment, but you want to, if you wanted to put a small cell back, a small cell at the end of that street, cnWave becomes a nice alternative solution to extend that down that narrow street and provide that coverage. Also worth pointing out, the performance in the red box on the right here is a 1.9 gigabits per second in each direction. So really high capacity connectivity there. And that's designed to, and you can see this is an output from our link planner tool. So it's actually been designed to carry at least 100 megabits per second out to 6 nines availability. I don't show the 5 nines on here, but that's a very high availability link. I mentioned the deployment status of cnWave. So this product was launched back in fourth quarter of last year and has continued to roll out, and we're ramping up the factory as fast as we can. We're seeing those products start to arrive in the channel and in the market here over the last 30, 60 days, but certainly we see that expanding or ramping up over the next 90 days. We do have, before we launched the product though, we did 40 plus proof of concept trials around the world. You can see the breadth of the trial and the breadth of the applications of this product is really a global in nature. 60 gigahertz is available in many, if not most, if not all countries, not all, but certainly a lot of countries around the world, and we've done trials in all those places. So many of these networks have actually been up for 9 months or more. So there is a lot of run rate track record with these deployments that we've learned over that time. And so the product is quite mature even as we're ramping up and getting this out to end customers here in second quarter. Here's just a typical example, but I wanted to kind of show as a combination of the different products. And this also starts to give us an idea of range and capacity, which we'll talk about that towards the end of the session as well. But this is a, when we talk about our V5000, which is our distribution node, and the V3000, which is the high capacity and high gain client node, you can see the uplink and downlink capacities are about just in UDP, just a little over 1.8 gigabits per second in each direction. So these are bidirectional or FDD type quoted rates. And then TCP drops to about 1.75. And then if you're passing traffic at the same time in both directions, you'll see it drops a little bit. The other combination is a V5000, which is the distribution node talking to the mid-gain client node, the V1000. You'll see that the capacity there drops. That's not driven by the air interface, but driven by the gigabit per second physical interface on the wired interface on the V1000. So it's got a gigabit RJ45 or gigabit port on the V1000 that does constrain that to a gigabit in each direction. And then similarly with the V1000 to V1000, you can see that that similarly as the sort of the lowest cost point to point, but also relatively short range, and because of the lower gain on those products. So that was a lot of applications and a lot of different ways that people are deploying these products, but ultimately they all come back to the same 3 devices. So I want to spend a little bit of time talking about what the actual products are, but suffice it to say that with these three products we're going to talk about, you could do all those different applications that I mentioned on the previous slides. First one here is the V5000. This is the distribution node, and a couple things that are unique to Cambium's approach to this with cnWave. This is a dual sector device, and each sector covers 140 degrees coverage with beam steering. So a lot of people ask, well, how come it doesn't do 360 degrees? And really what we've learned and in early concept development on this, and it's really proven out over time with these dozens or up to 100 different deployments. And actually we've done designs of more than a couple hundred different designs at this point, is that with the line of sight requirement and the mesh deployment topology, that we've never had to put more than one of these on a single post or tower or building. That because of the nature of the mesh and the nature of requiring line of sight, that mounting this on a building or mounting this on a post, you still, if you're going to mount it mid post, you're still going to have some loss in that sector behind you anyway. So what we find is that this is really a nice combination in that it gives us high gain in those individual sectors in a dual sector environment. You can see this does do different modulations from BPSK up to 16 QAM. It does adaptive modulation. This does 1.9 gigabits per second uplink and 1.9 gigabits per second downlink. So simultaneous, as I showed on the example before. And in second half of this year, we'll introduce channel bonding, which typically doubles the capacity. When I say typically, it means that in almost all modulations, you're going to see double the capacity. The very highest modulations, you may not see it absolutely doubling the capacity, but you will see as high as 2.7 gigabits per second uplink and 2.7 gigabits per second downlink in a single sector, and you can then double that with the two sectors. So talking about lots of capacity here, and it's all done in a single channel. So you don't have to worry about multiple channels or channel planning. What you're really looking at is how to best leverage that high capacity into your mesh. The configurations of this device, as I mentioned, it's two sectors, and each DN sector can talk to two other DNs. So a V5000 can talk to up to 4 additional distribution nodes. So each sector talking to two additional, or you can talk to, and or mixture, you can talk to up to 30 CNs. So and that's 15 CNs per sector for a total of 30 CNs. So that gives you a sense of the dimensioning or expansion capabilities within the product. And really, when you think about this, it's not so much about putting a very large access point and serving hundreds of endpoints. You really have to think of this as a distributed network. If you're going to serve lots of end users, you want to look at this as a distributed network with multiple entry points into that mesh coming into the different distribution nodes, and then distributing and sharing that capacity out to the different client nodes as you get to the edge of the network. So don't think of it as aggregating into these massive towers, but think of it as a distributed type of capacity. Latency is excellent on this product at less than 1 millisecond. And if we look at the interfaces, I think I'll go to the next slide. On the bottom of the device, you'll see there's 3 physical interfaces. The PSU port offers up to a 10 gig interface. It's a PoE input, so that you can provide, you can power this off of either a PoE power injector or with a DC supply. And we have a little adapter that allows you to plug a DC supply right into that PSU port. There's an aux port that does up to a gigabit per second output. That's also provides PoE out. So if you power this with enough up to 60 watts of power, you can now hang a device off of that 802.3 AT PoE out port, which makes an excellent solution to either power a Wi-Fi access point or a camera directly off of the V5000. We also, of course, offer a SFP plus port. That's a 10 gigabit per second SFP that you can plug in a variety of different SFP modules that we offer as accessories. So that's the distribution node. On the client nodes, there's two different models. The V3000 actually comes now in two different flavors. This is just recently introduced. The V3000 is what we call our high gain client node, and that combines the radio with a 44.5 dBi antenna. And then we recently introduced a slightly lower gain, smaller form factor 40.5 dBi antenna. This is really a great solution for as a client node for longer range, or as a point-to-point link pointing two V3000s at each other, and then having them pair up to become a longer range point-to-point link. And I'll show you some examples of what kind of range we're talking about here in a moment. You can see the azimuth here is pretty tight, plus or minus 2 degrees, plus or minus 1 on the elevation, but you are able to do, with all of these products, they support beam forming or beam steering, so that once you have it aligned within that range, the beam steering will actually initially aim that beam and optimize it. And then through what we call periodic alignment, it will also check that and fix it and improve it or optimize it over time. We support in the roadmap, we'll be supporting IEEE 1588 transparent clock. This is really useful for small cell backhauls as you try to push precise timing protocols over the network. I mentioned the 1 millisecond latency, so really makes a nice multi-gigabit per second point-to-point link if you're looking to connect. Again, those topologies are examples we talked about, which is connecting two buildings together. And that, by the way, that V3000 has the exact same ports on it as I mentioned on the previous slide. So the V3000 has the exact same physical ports that you see on the V5000 are available on this, the 3000 as well. And then for a mid-gain client node, this is really the device we see deployed on the side of residences or for small businesses serving a single user or a single client at the end of that, as sort of a spoke off of the mesh. This has many of the same characteristics. It does have a 1 gigabit per second physical port, but it has a much wider beam antenna beam. So you see plus or minus 40 degrees, plus or minus 20. So really the alignment and aiming of this back to the distribution node is very simple. You get it within that range and it will auto align based on the automatic beam forming. So really makes this easy to deploy. I also mentioned about the zero touch provisioning. All of the configuration and setup of this gets pushed down from the E2E controller and gets handled at the time of initial provisioning. So there's very little once you're actually out installing this in the field. You just makes it very easy to hang on a lamppost on the side of a house, and now you have access back to that distribution node. Low power consumption. One of the things that we're continuing to see benefits of this product, because there are lots of radios and there are lots of short links. The total cost of ownership of this solution, one of the aspects of that is keeping the power consumption low. So this is around 10 watts. Power consumption becomes pretty interesting when you're deploying lots of these networks or lots of these nodes around the area. A little bit about range, because I know that's of interest here, and also about the impact that not only range has, but rain has on 60 gigahertz solutions. So you have to worry about two things with 60 gigahertz. The frequency does not propagate as far as just based on the physics. As you go up in frequency, the propagation is less. You also have I guess you call it the concept of oxygen absorption, so that at 60 gigahertz, you'll also have additional link budget loss or propagation loss due to oxygen absorption. And then of course, rain can also impact this. So it's important to note when you build these networks, you should really use the link planner tool from Cambium. We also offer the ANP tool, and the ability to do planning is important to this. But let's look at a couple of specific examples. This is showing a V5000 distribution node to another V5000 distribution node, which, as it turns out, it can also be the same link budget to a V1000 because the antenna gains are the same. On the left, you see the waterfall curve showing with rain, and this is a typical amount of rain. And then on the right with no rain. And Link Planner automatically adjusts for this. So when you put the physical location of the links anywhere in the world, it will adjust not only for the oxygen absorption rates, but it will also adjust for the amount of typical rainfall seen in that environment. So what we see typically is that you would design this network for the amount of rain that you would expect. And in this case, you can see on the capacity about a gigabit in each direction, so a 2 gigabit per second link, and out to about 150 meters, you're going to see that range, and out to about 50 to 100 meters, you'll be up in the higher gigabit and a half to 2 gigabit per second range. And again, these are single direction rates. So that's 1 gig from DN to DN and 1 gig back in the other direction. If you then look at without rain, so in cases on sunny day, you'll see that actually goes out further, and you might get as far as 250 to 300 meters for V5000 to V5000. So while you would plan it in this 100 to 200 kilometers, or even 150 meters between nodes, without rain on a sunny day, you'll actually do a little bit better than that. And then here is another example with the V3000 talking to a V5000. So now I have the high gain client node, and you can see my link availability goes out farther. So when I'm talking from a distribution node out to an end client node, you'll see the range can increase. And with no rain, and depending on the channel you use, you see channel 4 always operates a little bit better because of the oxygen absorption at that frequency. But you'll see it about a little over a gigabit per second out to as far as a kilometer. And we have several links going at around 1.2 to 1.4 kilometers using either the V5000 to 3000, or in this last example, the 3000 to 3000. So here you can see it's possible to achieve that 1 kilometer or more with no rain, and out to about a half a kilometer with the rain. With a 3000 to 3000. So this is a point-to-point link using 2 of those high gain client nodes. So I've thrown a lot of material at you. Let me just summarize what cnWave's all about. The focus here is low total cost of ownership. So the V5000 with its 280-degree coverage, dual sector, no need to have multiple a site router or a switch at the tower. You can that dual sector is all integrated with a single PoE drop. So as you put these out in the mesh topology, you don't need a lot of additional equipment at each site. You have different ranges with the V1000 short range, the V3000 in 2 different sets of antenna options there. So you can have different ranges. You can kind of size the client node for the range you're looking for. And then auto beamforming makes all of this very easy to install. If you want to do the super long range with the V3000, you can do that. It's got the beamforming. We also have a site to put a telescope on, and you can see to help with aligning that. And then once you've got it roughly aligned, then the beamforming takes over and closes that link. The channel bonding hardware is ready. You can, like I said, you typically double the capacity, and that will come as a firmware upgrade later this year. IP6667, so all of these are ruggedized, built and designed by the team that brought you the famous PTP 670 and the PMP 450M. Very robust designs from the hardware standpoint. And then lots of high density deployments, whether you're talking about DNs going out in that mesh with supporting each DN can support up to 4 DNs down the path, as well as up to 30 client nodes. All of this is managed with CN Maestro, and we have planning tools, including both Link Planner and the ANP tool that I mentioned. So let me pause there. That's the prepared slides and material, but I wanted to leave plenty of time for Q&A as we close out the webinar today. I do appreciate everybody joining. There is a lot of additional material on cnWave at cambiumnetworks.com. We have our community, which you can interact with other users that are deploying cnWave. There's also lots of knowledge base articles on there about how we recommend deploying it. You can obviously get all of the other material like the spec sheets and other material in there. And then we also have our learning portal. If you want to get involved in coming up to speed and get some training on this, that's certainly an option as well. With our learning management system, you can come in and get certified as a cnWave administrator or a cnWave installer.
So like I said earlier, that this webinar has been recorded, so we will share that with everybody, and we'll also have it posted on our YouTube channel. So thank you again. Thank you, Bruce. Thank you, attendees. Have a great day.
All right, thanks everybody.